transformers are the most important and the most expensive piece of equipment installed in high voltage, medium voltage. Although they are very reliable equipment, if power transformers are not properly monitored and maintained, they may fail catastrophically and cause severe power outages in an area or even in a country. For this reason, online monitoring systems have been developed and used in oil-immersed power transformers installed in the above-referred key substations. Transformer monitoring techniques vary with respect to the sensor used, transformer parameters measured, and measurement techniques applied. Since monitoring equipment is usually permanently mounted on a transformer, it must also be reliable and inexpensive. What is transformer monitoring? Transformers are key assets in the power grid and industrial processes. Transformer monitoring reduces business risk through providing better safety for workers and the public, reducing unexpected failures, reducing unplanned outages. The consequences of an unexpected transformer failure can be catastrophic, yet many failures are preventable. The condition of a transformer is only as good as its worst performing component. Transformer monitoring actively monitors various operating characteristics to make sure they are functioning properly. Transformer monitors collect data and send alarms to notify the user if something looks off. There are a wide range of transformer monitors available that can detect the symptoms of transformer failure by monitoring the cooling system, load tap changer, dissolved gas, bushing power factor and capacitance, partial discharge, oil levels, pressure, temperatures, and more. Transformer Monitoring System. TMS is built with a clear goal to help its users improve asset management and prevent critical equipment from unplanned shutdowns. With over 450 plus systems installed around the world, the TMS system sets the standards in transformer monitoring. Transformer Monitoring System is an object-oriented system SCADA system process-oriented system. It provides insight into the state of a transformer and its real-time service conditions. The system uses several key functions such as measurement of quantities, estimations based on measured values in transformer data algorithms, comparison of current and initial values trends, comparison of current values with those obtained from a model monitoring. Transformer Monitoring System benefits. 1. Fault detection, monitoring and diagnostic of all vital transformer parts, prevention of failures and unplanned outages, user-defined alarm limit and gradient setting. 2. Condition-based maintenance, optimization of transformer performance, improved asset management using overloading and lifetime expectancy estimations, integration of data for root cause analysis. 3. Modularity, applicable to all types of power transformers and shunt reactors, fits new or existing transformers from any manufacturer. For expert functions, advanced trending analysis tools, interpretation methods of fault gas analysis according to relevant IEC and IEEE standards, long-term data archive with event logging, automatically generated reports for stakeholders. Key competitor in the transformer monitoring system market are GE, ABB, Siemens, Doble Engineering Company, Eaton, Weidmann, Schneider Electric, Mitsubishi, Qualitrol, Concar, Schweitzer Engineering Laboratories, LGOM. Transformers types of failures. Winding and OLTC on-load tap changer failures dominate. Consequently, the focus of most monitoring techniques is to collect data from parameters that can be used to assess the condition of winding and tap changers. Dissolved gases in oil and partial discharges PD are common parameters monitored related to winding and insulation condition. Temperature and vibration monitoring are commonly used for assessing OLTC condition. Statistical data of failures in an oil-immersed transformer are OLTC, 41%. Windings, 19%. Tank, 13%. Accessories, 12%. Terminals, 12%. Core, 3%. Common online monitoring systems and techniques. In order to reduce maintenance costs, save energy, and respond to advanced maintenance techniques, monitoring sensors for the transformer's main monitoring items have been developed. Oil-immersed transformer monitoring system uses information technology and is able to monitor the operating conditions of the transformer constantly, with sensors mounted in the transformer. Common online monitoring sensors and units are Gas and Oil Monitoring Unit, Oil Temperature Sensor, Oil Level Monitoring Sensor.
OLTC Operation Monitoring Unit. OLTC Contactors Consumption Monitoring Sensors. Overload Monitoring Unit. Dissolved gas and oil analysis is an effective diagnostic tool for determining problems in transformer operation. However, this analysis is typically performed off-post, where sophisticated and usually expensive equipment is used to determine gas content. To reduce the risk of missing incipient faults due to long sampling intervals, monitoring techniques are being developed to provide warnings with respect to changes in gas types and concentrations observed within a transformer. Conventional dissolved gas and oil analysis is performed after a warning is issued. By extracting the gas dissolved in the insulation oil of the main transformer and measuring the amounts of the 6 gas components at their low level, it is possible to detect local overheating or partial electric discharge in the unit depending on the analyzer data and to prevent any accidents before they occur. The main challenges to online gas monitoring are not only to develop accurate and low-cost sensors, but sensors that are versatile enough to detect the presence of multiple gases. Several new sensor technologies are now commercially available to measure concentration changes of multiple gases, and many more are in development. Oil temperature sensor. While inspections by personnel are conducted at longer intervals, the oil temperature sensor constantly monitors the transformer for any rise in oil temperature, and any internal or cooler abnormality can be effectively detected. Oil level monitoring sensor. While visual inspections are conducted at longer intervals, the oil level monitor can detect leakage from the transformer more effectively. Moisture monitoring sensor. The determination of moisture in oil is an essential part of a comprehensive transformer maintenance program. Oil-immersed transformers rely on the oil for cooling, protection from corrosion, and as an important component of their insulation. Excessive moisture contents in oil causes accelerated aging of the insulation materials and reduce their dielectric strength. In extreme cases, this can result in arcing and short circuits within the windings. Accurate moisture measurements can also warn about leaks in the oil system, as water is absorbed from the surrounding air. Moisture levels in oil are affected by temperature cycling of a transformer. The water solubility of the oil is temperature dependent. Water solubility increases as temperature raises. OLTC Operation Monitoring Sensor. Abnormalities in each block of the on-load tap changer are detected by the drive shaft torque and electric motor current waveform, which detect faults in their so early stages that accidents can be prevented. By performing effective emergency processing, the block in question can be identified during detection of abnormalities. Overload Monitoring Unit. By making an equivalent circuit mathematical model of transformer and by simulating the coil temperature by its operating conditions, load, oil temperature, cooler operation, and so on, which is difficult to measure, the operation tolerance time for abrupt by changing load and estimated load can be predicted instantly. Transformer temperature monitoring and cooling control. Why is transformer temperature monitoring so important? Temperature is a basic part of transformer monitoring. Temperature affects everything. If it is too high, it is indicative of a fault that could further damage multiple components of the transformer if left unchecked. There are several areas of a transformer where temperature is measured. Top oil temperature. Bottom oil temperature. Winding hot spot temperature. Ambient temperature. External compartment type on load tap changer.